family are, so I can't.
Like the first time, like
That sounds
Sorry about that. Reset, please.
the second time here.
So at the end of the class period yesterday, you were trying to draw the dot and arrow picture, the motion map to go with this. Is that true?
Yeah.
Now, we're good with this, okay? Let me just highlight this for a second. So this is already on your boards. We're just going to continue with it. So if the ball were to start here, okay, and it moves a little bit. Okay. Now, on your board, you're actually putting them at the actual positions, right? You have those numbers. Now, what do you notice about the spacing between the dots? It's increasing. What does that imply about the ball? It's speeding up as it rolls down, true? Okay, so if you go to put the velocity arrows on, what are you going to notice? They should be getting longer. Is that cool? So if I look at these here, one way to ensure this is just to draw it halfway from dot to dot. If you draw it halfway from dot to dot, you're good to go. For example, if I do the one before that, is that one going to be longer?
Yeah.
Okay, now I'm not going to draw them all because you're drawing them. Now, one of the things that we came to at the end of yesterday was kind of a definition. Okay? It was kind of a definition. When we graphed the position time, and then we graphed the velocity time, this was your actual lab, right? This one was a nice parabola. Okay? This one was linear. Is that cool? Now, we developed a third quantity. Our definition was the slope of the velocity graph is this new quantity. What's the new quantity?
Acceleration.
The acceleration, that's right. So what if I were to graph the acceleration time? If the slope of this graph is this value, what do you think this graph is going to look like? Check your neighbor, yeah. I go to graph the acceleration. Our definition is the slope of this is this. What's it going to look like? But this is a straight line.
It's also known as time. It's a line with zeros.
Because acceleration, and you can put like that, and that's linear.
All right. So there's a lot of good ideas out there. Let's see if we can't coalesce them into one idea. I'm going to look at this green line. Tell me two things about the slope of this green line. It's constant and it's positive. Right? So Noelle just indicated what this should look like. I think she's right. So she says, look, if the slope is constant and positive, then the acceleration is constant and positive. Is that cool? Mm-hmm. Now, here's the deal. We have this up here, yes? Is acceleration part of this? Would you say the ball was accelerating? Yeah. I would. Which means you have to now, on your motion map, include acceleration arrows. So there's one set of dots and two sets of arrows. So to do this, one thing you can do is you can just make your dots a little fatter. And include acceleration arrows. Is that cool? See, isn't that a great question? Why do you think I only drew one?
Because it's the same length.
But you see though, if I had drawn another one that was the same length, that would have implicitly indicated something that I wanted you to come to on your own. But you already did. Yes, Helen?
When we're graphing this, do you want the acceleration arrow to be in a different color?
So I'm always going to do red for the position dots, green for the velocity, blue for the acceleration. That's my jam. All right? But those three elements should definitely be different colors. Peter?
You want us to label like the actual amount of acceleration like we did on the previous velocity motion map?
No.
So just the arrows?
Yeah, I mean, you could put the values on, right? It doesn't matter to me. Like, if you knew this, let's say your acceleration was 20, right? If your acceleration is 20 and this velocity is like 40, you could put 40 and then 20. You could do it if you wanted. It's not necessary though. Okay, it's not necessary. All right, so here's what's going to happen. I'm going to say 3, 2, 1, go, and on go, you're going to move back to your laps. You're going to grab your whiteboards from behind Charlotte. You're going to finish your motion maps. All right. I'll be around to ask some questions, and then in about 10 minutes, we're going to come back here. We're going to present these whiteboards to each other. Are you ready? Set. Go. Yeah, fill it out. I need to sign it. Teachers aren't doing that, and